Okay, this is going to be the Algebra 2 Polynomials review for 2014-2015 school year. All right, so you should have this packet, so you can go ahead and follow along. All right, couple things that you want to look at first to determine positive, negative. Basically, every polynomial, okay, and I'm gonna go forward for a second. I want to go to a blank page so I can show you something. Every polynomial is going to be one of these four categories. All right, you're going to have the end points. What I'm talking about, the end behaviors, are either going to be one of these. Okay, so basically, this top part, all of these are positive. These are going to be negative. That's like a negative slope. If you think about that, that would be like negative x squared. So, and this is going to be odds, and this is going to be evens, okay? So everything is going to look like that, okay? So this is a negative slope, because that would be like the equation y equals negative x. That would be like y equals negative x squared. Obviously, this is y equals x equals x squared, okay? So that can help you in the concept of figuring out positives and negatives. So let's go back and look at my examples here. All right, so for instance, that's sort of like a line. The end behaviors is what we're looking at. Line there. All the stuff in between doesn't affect that. So that's going to be negative, okay? The degree, okay? Here's how you figure out the degree. You look at the turn points. You have two turn points. The degree is going to be 1 plus the turn point, okay? 1 plus the turn point. So in this case, this is degree 3, okay? All right, that's degree 3. We already talked about the turn points. There's going to be 2 turn points there. Okay? All right. Also, the degree, okay, the degree equals 1 plus the turn point. The degree also equals the max number of real zeros. Okay? That doesn't mean you're always going to have that, but you could have a maximum of that. So in this case, the degree is 3. So the max number of real zeros I can have is 3. Okay? Now, here I only have 1. They want you to mark a real 0 there. So I only have 1 real. That means I got to get to 3, so that's got to be 2 imaginary. Okay? So that's going to be 2 imaginary. So when you look at that, all right, understand that the degree, if I'm at 3, these have to add up to get to that. Okay? This is going to be negative, once again, because these are going down, so it's negative. Okay? I got 1 turn point, okay, which is right there. All right, go ahead and circle that. All right, that means if I have 1 turn point, that means I'm going to have 2 degrees, okay? 2 degrees. Whoops, that's not what I wanted to circle. Okay, 2 degrees, all right? That means if I have 2 degrees, I can have max 2 zeros. Now put an X, it's got to cross this line. That means I have 0. So if I have two possible zeros, 0 real, that means I got to get 2 imaginary, okay? As you can see, that totals up to get to that, so I got 2 imaginary in this case. All right, this end behavior is this way, okay? So that's going to be a positive, okay? I've got 1, 2 turn points, okay? All right, that means if I've got 2 turn points, 1 more for the degree, so that's degree 3, okay? So if I got 3 degrees, that's 3 zeros are possible, okay? Now, I've got 1 here and 1 here, but when it touches that line, let me erase that X real quick. When it touches like that, this one's called a double root, okay? Double root, okay? So that actually counts as 2. So that's 1, and then 2 more is 3 real, okay? So I got 3 real and 0 imaginary, okay? Because that's got to total up, all right, to give me the possible number of zeros. Okay, let's scroll up here. All right, this one, they're both going down, so that's going to be negative. Okay, turn points, 1, 2, 3 turn points. Okay, if I got 3 turn points, that means I have 1 more degree, so I have 4 degrees. So that means I got 4 zeros are possible. Okay, now watch, I got 1, 2, 3, and 4. So I can go ahead and mark all those. So I got 4 real. That means in order to get to that, I need 0 imaginary, okay? So I have 4 real, 0 imaginary, okay? All right, this has 1, 2, 3 turn points, Both those are going up, so that's going to be positive. Okay? One more degree is 4. So I've got 4 zeros are possible. Let's talk about real and imaginary. Okay? Alright, it crosses once, twice. Okay? So I got 2 real. That means I got a total up there, so that's 2 imaginary. Okay? Alright? This one, I have one turn point. Okay? Alright? Both those are going up, so it's going to be positive. If I got one turn point, I have 2 degrees. So I got 2 zeros are possible. Okay. Now, once again, that touches, there's a double root there. Okay? That's a double root. Alright? So that means that counts for 2. So that's 2 real, 0 imaginary. 2 real, 0 imaginary. I already marked that. Okay? Use your calculator to find the coordinates of any turn points here. Okay, so what I'm going to do, hold on one second. Gotta pull up my calculator. Okay. Alright, I'm going to go ahead and graph this. Okay. Menu and graph. Alright. X cubed minus 5x squared plus 3x plus 12. Okay. I'm going to draw. I'm going to zoom. Actually, I'm going to do, hold on. I'm going to do F3, exit and draw. So I got that. I'm going to zoom out a little bit. Zoom out, enter. So I got that. So I got turn points here and here. All right. So what I'm going to do is I'm going to do GSolve max. Okay. I only got one max turn point. So that's going to be 0.3 comma 12.5. Okay. 0.3 comma 12.5. Okay. That's going to be my max. My local max. Okay. GSolve minimum. Okay. I've got 3, 3. Okay. 3, 3. All right. That's my local min. I have my local max. Okay. All right. Okay. So that's the turn points for there. Given the graph of g of x on the right, identify each turn point with an x on the graph. Okay. So my turn points are going to be here and here. Okay. All right. Given the graph at the right, identify the x intervals. Okay. So I'm going to go ahead and let me erase that real quick so I can count. 1, 2, 3, 4, 5. So that's -5, 0. Okay, that's going to be 1, 2, 1, 2, 3, 4, 5, 6, 7. So -2, 7. Okay, here are my turn points. Okay, so just like all these other things, all I care about are the x coordinates. So let's label my arrows just as a reminder. That's the left arrow, so that's -infinity. It's going up, so it's positive. Okay, this arrow is a right arrow. Okay, that's what I got like that. Okay, so if I'm doing the increasing, decreasing behavior, this is all I care about. So I start here. That's -infinity to -5. It's decreasing. -5 to -2. It's increasing. -5 to infinity. So it says circle all the ones that are increasing. Okay, that's going to be -5 to -2. Okay. Find the end behavior of this. Now, what I would do here to make this easier on yourself, pick out the highest degree. Okay, and its sign, okay, and its sign. So the highest degree in this is this, and it's negative. So here's what I'm going to graph. I'm going to graph just -x to the 6th power. The reason being is all this other stuff just warps the graph, it stretches it, it puts turns in it, but it doesn't affect the end behaviors, okay? So I got -5x to the 6th, and I'm going to draw it, okay? F3, exit draw. And as you can see, it's going like this. So, if I'm labeling this, this is obviously, let me move this up a little bit. Obviously, this is a left arrow, which is -infinity, -infinity because it's going down. This is positive and -infinity because it's a right arrow and it's going down. So it says circle the end behavior. Okay, as x approaches -infinity, y approaches negative. That's one of them. As x approaches negative, y approaches positive. That's not right. Okay, as x approaches positive, y approaches negative. That's the other one. Okay? All right, and x approaches negative, y. So all you got to do is label those arrows. So we should be good at that by now. Okay, state the zeros and give their multiplicity. Very simple. X squared, that 0 is going to be x equals 2. multiplicity of 2. Okay, x plus 5, if you want to look at it this way, all right, that's just going to be x equals negative 5. All right, that's going to be no multiplicity. And then x minus 4 cubed, all right, that's really this, which is really going to be x equals 4. You're just changing the sign. That's a multiplicity, okay, of 3. All right, all the zeros of the polynomial. Write the equation of the polynomial in factored form. Okay, so multiplicity of 2, I'm going to put my f of x, means x minus 3 squared, because it would be 2. Okay, if that's going to be that, that's going to be x plus 1. So I'm changing the sign. Multiplicity of 2, just make that the exponent. Write out the equation of the polynomial in standard form. So what I'm going to do, all right, is I'm going to, squared means write that twice. So I'm going to use my boxes. That's x squared, negative 3x. Negative 3x and 9, okay? So I got x squared minus 6x plus 9, okay? Now, I'm going to multiply that by x plus 1, okay? So what I'm going to do is I'm going to do this. I'm going to write x squared minus 6x plus 9, x plus 1 going this way. That's x cubed, x squared, negative 6x squared, negative 6x, 9x, and 9. Once again, the diagonals is just like factoring stuff. The diagonals are the ones that are going to combine. So what I'm going to have for an answer out of this, I'll write it right here, is x cubed. All right, x and that would be negative 5x squared. Negative 6 and 9 would be 3. And then I got 9 here. Okay, so there's my answer there. Okay, picking up where I left off. All right, writing in characteristics of the polynomial here. What you have here is we've got 1, 2, 3, 4, 5, and 6. So that's at negative 6. That's a 0. 1, 2, 3, 4, 5. That's 5, and that's a double root. Okay? So when I make that polynomial in factored form, x plus 6, x minus 5 squared, because that's a double root. Now, what you have to watch out for, it's not the case in this, but since this is like that, that's positive. If that would have gone that way, I would have had to put a negative out front, so be careful of that, okay? Here it says sketch a polynomial as real 0 at negative 3 and at 5 with a multiplicity of 2. So here's what that means. Let's put the real zeros in first. Multiplicity of 2, 1, 2, 3, 4, and 5. So since it's got a multiplicity of 2, that means it's got a curve, okay? So what I should do here is this should go like this, okay? Because it's got a touch and go because it's double root. Now, I got 3 real, okay, because this counts as 1, this counts as 2, total of 3. They want me to put 2 zeros that are imaginary. So that's 2 imaginary. So here's what that means. I've got 5 zeros. That means I have a degree 5, okay? And if I have a degree 5, I've got to have 4 turn points. Now, as you can see here, I got 1 and 2. So what I got to do is I got to make 2 more, 1 and 2 more without touching down there because I don't have any more real zeros to use. So as you can see, I got 1, 2, 3, 4 turn points. That makes that logic work. Okay. This is a cubic. Now keep in mind our normal cubic function is 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. Okay. Now. My anchor point just is normally 0, 0, so my anchor point here is right there. So it's 1, 2, 3, down 1. So it's minus 3, minus 1. Opposite on the inside, follow on the out. I know it's a cubic, okay? Now, normally I go right 1, up 1, but now I go down 1. So if I go down 1, and if I go right 2 and then down 8, the only way that becomes is I would have to multiply by negative 1. So that gives me that, okay? Moving on. Once again, same old cubic numbers, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. I'm starting at negative 3, 1, 2, 3, 0. All right, and so I'm going right 1, up 1, right 2, up 1, 2, 3, 4, 5, 6, 7, 8. Left 1, down 1, left 2, down 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so here's my graph. Okay, now this is a quartic. My quartic graph, let me make sure I can see that over there. Okay, yep, I got plenty of room. All right, so my normal quartic graph is 1, 1, 2, 16. Okay, negative 1, 1, negative 2, 16. It's very much like a quadratic, but obviously you're doing it to the fourth. Now, my anchor point here is 0, 2, okay? 0, 2. So I'm going 0 over 2 up, okay? Now, since I got that negative 1/4, I'm multiplying these by negative 1/4, okay? And I know it's hard to see that, but basically that's going to be negative 1/4. 16 times negative 4 is negative 4, okay? So I'm going right 1, down a fourth, right 2, 1, 2, down 4, 1, 2, 3, and 4. Left 1, down a fourth, left 2, down. So it looks very much like a quadratic. It's just going to be stretched a little longer, okay? Moving on to 18, division of polynomials. The way that works, okay, 2x and negative 1. This first term goes in here. So what that tells me is I'm going to have an x squared, I'm going to have an x term. Okay, I might have a remainder, depending. This times this has got to give me that. The only possibility there is x squared. The logic now tells me it's this times this gives me this, which is negative 1x squared. Now, these diagonals have to get to, if it's x squared, it's got to get to this number here. So the only way to get there is to get to negative 6. Negative 1 minus 6 is negative 7. Okay? Now, this times this has to give me that. The only thing that would work there is negative 3x, which tells me that this has to be 3x. Now, my diagonals here have to get to 11, so this has to be 8. The only way that works is that's 4. If I multiply that, it's negative 4. Now, my number here is 5. So this is where I'm going to have the remainder. I got to get to 5. Well, how would you get to 5? You would add 9 to get to 5. So my answer here to this problem, I've used this already. So this can't be part of my answer. It's going to be this, 3x plus 4, plus 9 over 2x, I should have erased, let's cross that out, 2x minus 1. Okay? And there's my answer there. It says completely factor. Okay? All right, state and then find all the zeros. So what I'm going to do is I'm going to go to equa here. All right, I'm going to go to menu and equa. I'm going to see if I can find any of the zeros. So my polynomial at degree 3, all right, I'm going to type in 1. The x squared term is negative 1. Oh, whoops. Is negative 1. My x term is negative 5. And my term over here is negative 3. And I'm going to solve. Okay? Now, what that means for me is I got x equals 3 and x equals negative 1 is repeated twice. Now, since it's degree 3, max number of real zeros, so I'm finished. The factors of this are pretty simple. X minus 3, x plus 1, x plus 1. You could have also written it as x minus 3, x plus 1 squared, because it's a double root. Okay? Moving on. Okay? Is this a factor? Okay? A couple of ways you can know that. If this is a factor, then 2 would have to be a solution. Okay? And if 2 is not a solution, that doesn't work. So I'm going to type in 2, 8, negative 3, negative 1, solve, and 2 is not a solution. Okay? The other way you could do it is divide this and see if there's a remainder. So that answer is no. You can either 2 is not a solution. Another type of answer would be no, or, all right, no, because there's a remainder. Because of remainder. Okay? All right. Given this, divide that, okay? We're going to go ahead and do that. So once again, I'm going to start 3x cubed is going to go in here. 3x plus 1. Since it's x cubed, I know I'm going to have x squared. I'm also know that I'm going to have x, all right? The only way this works is if this is x squared. This times this has to give me that. That's 1x squared, okay? I got to get to 7, so I got to put 6. Whoops, I don't need that little line there. Okay? Okay? The only way that works is if that's 2x. Okay? Alright? That would give me 2x. I got to get my x's to be negative 13, so that's negative 15 is the only way that would get to negative 13. The only way that logically works is that's negative 5, okay? All right, and this would be my answer would be negative 5 there, okay? Negative 13, I'm going to double check that that's right, all right? And then that's going to be the remainder there. Let's see, this is not the one where you have to find all the roots, is it? Okay. All right, let me double check that I'm doing this right. Because you shouldn't end with a positive, a negative answer there. Okay, so, all right, so what I need to do is I'd have to go to plus 10. Okay, all right. Actually, hold on, I'm going to pause this video for 1 second, make sure this is the right problem. Okay, picking up where I left off. We're not going to have a remainder on this. Okay, this problem, you'll get this adjustment in class, is going to be negative 5. So if that's the case, then I am done. My answer would be x squared plus 2x minus 5. Okay. Now, when you get down to this, okay, what is the complete factorization? What are the roots? What are the solutions? Okay. What I would do here first is figure out the roots and solutions, because that's going to tell you what the factorization is. Okay. So I'm going to go back. I'm degree 3. Let me go to my original problem so I can see it. Okay. All right. So I would type in 3. Okay. 7. All right. Negative 13 and negative 5. Okay. And I hit solve. Now, these are nasty. Negative 1/3 on your calculator would turn into that negative 0.3 is negative 1/3, and this is a nasty one. So what you know is that when you have two nasty ones, you have to use the quadratic formula. So I know that one of the roots is x equals negative 1/3, x equals negative 1/3. The solutions and roots mean the same thing. The other two I'm going to have to find with the quadratic formula. Now, which part do I do that with? After you do the division, okay, this part left over is what the quadratic formula is going to be based off of. Okay, so you'll get the quadratic formula, but basically it looks like this. All right, so what I'm going to do is I'm going to go back to my menu, and I'm going to go back into run, okay, and I'm going to put some of this stuff in here, okay. So I'm going to put 1, all right, so this is my A is 1, this is my B, this is my C, okay. All right, so I'm going to do 1 arrow alpha A, 2 arrow alpha B, negative 5 arrow alpha C. I'm doing that B squared part first. B squared minus 4 alpha A alpha C. Okay? And what I got is 24. Okay? So I'm going to reduce the square root of 24, 2 and 12, 2 and 6, 2 and 3. Can't use these anymore. There's my pair. Okay? So what I got is I got 2 square root of 6 plus and minus. All right? The 2A, that's going to be 2. B, that means that's opposite, so it's going to be negative 2. So if you look at all 3 of these, they all have 2 in common. So I can divide them all by 2. So my solution here is x equals negative 1 plus and minus square root of 6. Okay? Because all those divide by 2. The same thing here. Now, as far as the factorization, I got a factor already in 3x plus 1. If what you got was a nasty decimal, you use just that part of the quadratic formula that you did to get the other factorization. Okay? All right? What is the complete factorization? What are the solutions? Once again, let's find the solutions first, and then we'll figure out, okay, the other part. So I'm going to go back into equa. I'm going to type in polynomial degree 3. I got 2, I got 1, I got 6, and I got negative 18. Oh, whoops. 2, 1, 6, negative 18. And I solve. Okay, now, what you might have to do is, as I can see, you got one nice one, okay, all right, that will turn into fraction decimal, will be 3/2, okay, and 2 imaginary. Okay, and I'm going to have to work that out with the quadratic formula. Now, if your calculator is not in that mode, shift menu, make sure your calculator is set in A plus BI mode. Okay? All right, I'm going to go back in here. Whoops. No, I don't want to delete the coefficients, I want to solve. Okay, so I know that one of mine is x equals 3 over 2, okay, which as a factor would be x minus 2/3. Now, what I should do with that is I should divide, which would turn into 3x minus, or 2x minus 3. Hold on, I did that backwards, sorry. That's going to be x minus 3/2, which would be 2x minus 3. So what I'm going to have to do is I'm going to have to divide by 2x minus 3. I'm going to put this 2x cubed in here, all right? And I know that I have to have an x squared term and an x term. The only way this works is this is x squared. That's negative 3x squared. Okay, my x squared terms, this is a 1, so I got to get to 1. So that's going to be 4, because that would give me 1. That would be 2x, okay, which would give me negative 6x. All right, that's a 6x, so if I have to get there, I have to go to 12. Okay, only way that works is multiply by 6. That gets me negative 18, and that's good. So what I'm going to have there, I already know that that's nasty, so I'm going to go ahead and put that as my factorization. Because that's nasty decimals. If you get nasty decimals like that, and you get that answer, you already know that's good. So I'm good with the factorization. We're good there. Okay? Now, to get the solutions, I'm going to use the quadratic formula again, where that's my A. All right? That's my A. That's my B. That's my C. Okay? So I'm going to go in and do, I'm going to do 1 arrow alpha A. Okay, 2 arrow alpha B. Okay, 6 arrow alpha C. Okay, and I'm going to do alpha B squared minus 4 alpha A alpha C. Okay, I got negative 20, and that's what I should get because I got imaginary. Okay, so I got square root of negative 20, which is 2 and 10, 2 and 5. Okay, I got that. Now, since I got that negative, I'm going to have plus and minus 2i square root of 5, because I can't use those anymore. Okay, the quadratic formula says take the opposite of this, which is negative 2. All right, and then 2a. My a is 1, so that's going to be 2. All of those are divisible by 2. So my answer here is negative 1 plus or minus 1i square root of 5. Okay? Moving on, factoring cubics. Now, this is just like the division. I'm going to put 8x cubed in here. Now, I've got to figure out this, and what I do is I take the cube root of both parts. Now, be careful, especially on these Casios, make sure you get out of a plus bi mode if you want to do the cubic, because for some reason it messes up there. So I want to do cube root, cube root of 8, cube root of negative 27 gives you negative 3. The other shortcut there is if that's a minus, that's got to be a minus here. So whatever sign's here, it's the same one. So that's 2x. Okay. Once again, all the logic goes from there. If I'm at x cubed, I know I have to have x squared. I know I have to have x. Okay. That's going to be 4x squared, which would be negative 12x squared. Now, if you notice, I don't have an x squared term, so these got to cancel out or eliminate. So that's got to be 12. That's got to be 6. That's got to be negative 18. Once again, these have to cancel out, so that's got to be positive 18. All right, that's got to be 9. That's going to be negative 27. Now, since I had to come up with both of these on my own, both of those are a part of my answer, okay, because that's my factors, okay? Factor this, okay? Now, a lot of people get confused with the y cubes. I'm going to show you a little shortcut with that, all right? But basically, we're going to start. I'm going to worry about, we'll do the y's second. Let's get all the numbers right first. So I got x cubed. So I'm going to take the cube root of this, cube root of this. Cube root of 1 is 1x, okay? Cube root of 64 is 4, positive 4. So I'm going to worry about the x's first. And we'll get to the y's in a second. Let's make sure we get our numbers right. X squared and x. All right, the only way this works is x squared. That's going to be 4x squared down here. As you can see, I've got no x squared term, so that's got to be negative 4. This times this has got to be negative 4x. That's got to be negative 16x. The x is eliminated, which is positive 16. Okay? This is positive 64. Now, on the surface, we're good there. Now, to introduce the y's if you want, okay, cube root of y cubed would just be y. Okay, so let's add a y here. Well, what does that mean here? For us, that means that has to be a y. In order for that to be the case, that's got to be a y. Okay? All right, if that y is there, then that means that's going to be y squared. Well, if I have a y squared here, I got to have a y squared there. Well, this time this has got to give me that, which is y squared. Okay? And the only way that works, y squared. Or y cubed, I'm sorry. Okay? All right, now, another simple way to do that is if with the y cubed, you could just put a y and a y squared there, make sure that last term works. So I got x plus 4y, x squared minus 4xy plus 16y squared. Get the numbers, though, first, okay? The only difference between this is you're going to have y here, and a y squared there. Make sure those last two terms multiply. You got to have a y cubed, okay? All right, here's another one that you can do. You know, on my calculator, it doesn't eliminate quickly for that. Okay, so I'm going to go get another one. Okay, what you can do is you can type this in going across. If you go to menu and equa, okay, so if I go to menu and equa, my degree is not going higher than 3. So yours will. So go to 4, and what I'm going to type in is 9. So if you're typing in 9, 0, negative 37, 0, and 4. Okay? All right? So 9, 0, negative 37, 0, and 4. If you hit solve, okay, you get these solutions. 2, basically 1/3, negative 1/3, negative 2. Okay? So, as factors, all right, I'll take care of the 2's first. That would be 3x minus 1, 3x plus 1, okay? That's one way of doing it. If you want to use the boxes for this, okay, if you want to use the boxes for this, all right, I got 9x4, okay? All right, I got 9x4. That means I'm going to have an x cubed, an x squared, an x, okay? All right? Okay, so you could do this very similar. So what you're looking for, actually you don't need to do all those, sorry, hold on. This is very similar to our other quadratics where we multiplied 9 and that would give me 36, okay? So what I could do is 9x4, okay, and this is 4. I got to have 36. A match of that would be negative 1x squared and negative 36x squared. Those would get me negative 1 and negative 36 would add up to negative 37. And you could do the GCF here, which would be 9x squared, okay? The GCF there is negative 1, okay? GCF here is x squared. GCF here, because that's a negative, would be negative 4. So what I would have is, I got 9x squared minus 1, okay, x squared minus 4. Now, our shortcut on that, because that's our old stuff like that, is 3x plus 1, 3x minus 1. This is x plus 2, x minus 2, okay? So what I got there is those solutions, or that's actually my factors right there. So either way, you can make that work, okay? All right? There's all kinds of possibilities. You might get a couple real ones, and you might have to divide. There's all kinds of ways to do it, okay? All right? I think that was the last one on that page. Yep. Okay. Now we're going on to these. We need to get these. We need to get better at these. F of g of x. So what that means is I'm going to lead with the f function. Be careful. Make sure you watch your letters. Okay? Lead with the f function. So that's 4 plus 5. Okay? Space there. I'm going to lead, put in that behind it. So I got 4x squared minus 12x plus 5. Which is D. Okay? F of g of negative 2. Now, the only difference is it's the same problem, but we desperately need to use our calculators. We'll go back here. Okay? All right, I'm going to put in, they want me to put in what? Negative 2 for x. So negative 2 arrow alpha. Or I don't even need alpha, I just need x. Okay? Then type that in. 4 x squared minus 3x plus 5. Whoops, too many x's over there. Okay, 45 is my answer. I got that right. Okay. I think that's it. Oh, and that's my stuff from the beginning. Okay, so go ahead and watch that, practice that up, use your calculator, you should be fine.